You know, every skyscraper, every house, pretty much every single structure you've ever looked at has a secret. It has this powerful, unseen hero holding the whole thing up. Today, we're going to go underground and find out what it is.
So, let me ask you, what do you think is the most important part of a building? Is it the roof, the walls, maybe the cool architectural design? What's the one single piece that's the most critical?
You got it. It's the foundation. The part that's completely hidden from view, doing all the heavy lifting. And really, if you want to understand how our world is built, you have to start right there.
So let's just dive right in. What is a foundation? And what exactly is it doing for us, buried down there in the dark? Well, here's the textbook definition. At its core, a foundation has one single crucial mission. Take every ounce of weight from the building, every floor, every beam, every single person inside, and spread that load safely across the ground. It's the handshake between the building and the earth. And we can break that mission down into 4 key jobs. First, like we said, it spreads the weight. The best analogy is snowshoes. You weigh the same, but the snowshoes spread your weight out so you don't sink into the snow. That's exactly what a foundation does. It also stops the building from sinking unevenly, tilting. It prevents it from sliding sideways. And ultimately, it just makes the entire structure stable. Now, for any engineer starting a project, the very first decision they have to make is all about this. How deep do we go? And that one choice splits the entire world of foundations into 2 big categories. This chart shows that decision perfectly. You've got shallow foundations sitting pretty close to the surface, and then you have deep foundations, which have to dig way, way down to find solid ground. In this explainer, we're going to stick with the shallow end of the pool and look at the 5 main types you see branching off right here.
So what's the actual difference? Honestly, it's a surprisingly simple rule. If the foundation is wider than it is deep, we call it shallow. If it's deeper than it is wide, we call it deep. That's it. So simple, but it changes absolutely everything about how you build.
All right, let's start with the most common, the most straightforward types of shallow foundations. I mean, these are the real workhorses of the construction world.
First up, we've got the isolated footing. Just look at this thing. It's so simple, right? It's just a single concrete pad, and its whole job is to support one single column. It's the most basic solution for the most basic problem. How do you hold up one post?
And there's a reason it's the go-to solution for so many projects. It's cheap, it's easy, it's economical. As long as the ground underneath is good and strong, this is usually the best choice for regular buildings, say up to about 5 stories tall.
Okay, but what if your weight isn't concentrated in one spot? What if it's a long, continuous line, like a load-bearing wall? You can't just stick a single pad under a wall. You need something that supports it along its entire length. And that's where this comes in, the wall footing, sometimes called a strip footing.
It's basically just a continuous concrete ribbon that runs right under the wall. As a general rule, the footing will be about 2 or 3 times as wide as the wall that sits on top of it. And just like the isolated footing, it's super economical, and it works great when you're building on firm ground, like dense sand or gravel. But, construction sites aren't always perfect. Sometimes your columns are too close together or you're building right up against a property line. When that happens, engineers have to get a little more creative.
Check out this photo. See how those columns are all bunched up together? If you tried to give each one its own little isolated footing, the concrete pads would just overlap and become a mess. So, what's the solution? Well, you just combine them.
And that is exactly what a combined footing is. It's one big foundation that's designed to support 2 or more columns at once. It's a really elegant fix for a super common problem, and it makes sure the load stays distributed, even when space is tight.
Okay, new problem. Let's throw a wrench in the works. What if you have to build a column right up against the edge of your property? You can't just pour your foundation onto your neighbor's land, so what do you do then?
The answer is this really clever piece of engineering called a strap footing. What you do is you build a footing for that awkward column on the edge, and then you connect it with a big concrete beam, that's the strap, to an interior footing that's more stable and centered.
That strap is the key to the whole thing. It acts kind of like a lever, using the stability of that nice centered interior column to balance out the off-center load from the column on the edge. It's a fantastic solution for those tricky situations.
But what if the problem isn't your columns at all? What if the problem is the ground itself? What if the soil is weak or marshy and just can't handle the pressure? Well, that's when you have to bring out the big guns of shallow foundations.
This is a raft foundation, also called a mat foundation. And you can see it is absolutely massive. Forget about individual pads or strips. Here, you pour one giant, thick,
Steel-reinforced slab of concrete that covers the building's entire footprint. I absolutely love this quote from our source material because it's the perfect way to picture it. With a raft foundation, the building acts like one solid unit, almost like a boat floating on a sea of weak soil. It just spreads that massive load out over the biggest possible area.
So you can see, you use a raft foundation when the stakes are really high, when the soil's just plain bad, when you have incredibly heavy loads from columns that are packed tightly together, or when you absolutely, positively cannot have one part of the building sinking more than another. It's the ultimate problem solver.
So, next time you walk into a building, just take a second and think about what's holding you up. That invisible foundation. It's like a written record of all the problems that had to be solved before a single wall could be built. The ground under your feet isn't just dirt. It's the beginning of a story. So,